My name is Owen Diamond and I'll be giving a presentation on the history of the personal computer. Setting the stage. A computer originally, before we had computers as a device, was an individual who did mathematical computations. I think considering the first computer, this was a fitting name. 1822 to 1910 can be credited with the creation of the first computer. Most people would credit this to Charles Babbage, who created the difference engine. Its sole purpose was simply to make computations with numbers, so I think the name computer is a fitting choice for this type of device. Then in 1910 to 1940 we have what I like to call the great monoliths of computer history. Of course, like everything, war kind of spurs technological advancement. So between World War I and World War II, we had these computers created to help us with the war effort. A few examples would be the Bombay, which was this massive computer used in World War II to help decrypt enemy communications. And then you had other huge mainframe type computers such as the ENAC and UNIVAC, which were used by the US military and government organizations like the Census Bureau, or also big corporations like Westinghouse and General Electrics. It's interesting to know that the UNIVAC, which was sold to the Census Bureau, cost about $1 million a piece. It was something like $750,000 for the computer itself, and then another $250,000 or so for the printer. And then in 1973, we had sort of a landmark case for computers. John Addison, who many consider to be the father of computing, got in a lawsuit with ENAC over copyright. Addison basically took them to court, and it was established by the judge that most of the information about computers and the creation of computers and the techniques and technology behind computers was actually already public domain at that point, since they were being developed since about 1910. So the judge actually declared computers themselves unpatentable. So this kind of really opened the floodgates for competition, because people were able to now create computers and release them to the market without having to pay licensing fees or patent fees. In 1971, we could say the first personal computer went on the market, but it kind of started out with a whimper. The first personal computer, also known as the Kenbach-1, was mostly used for educational purposes, just to kind of explain how computers work and to also educate people on how to program computers back then. I thought throughout this presentation it would be fun to demonstrate some of these old computers, so I have a emulation of the Kenbach-1 I'm going to demonstrate now. And this is kind of a depiction of what the Kenbach-1 looks like. It was basically a box. There was no display and there was no keyboard. You had a set of buttons and a switch on it. You would simply power the computer on with the toggle switch. And then you had this first row of buttons here. The first two buttons were the start and stop for running the computer once you had entered a program. The next two buttons were for memory. You could read what was at a particular memory location, or you could store a new value there. Then you had the address buttons. The display button would tell you what address you were currently set to look at, and then the set button would set a new address. Then you had the clear button, and you had a lock and unlock, which would allow you to lock the computer so that you didn't accidentally enter in values. The way it works is pretty simple. You would start off by turning the computer on, which you've already done, and then they recommend that you start and then hit stop on the computer. You can see down here I've got a memory viewer going with the emulator, so we can see what values are put in. Everything is done in 8 bits, so you had to know binary to use this computer. First thing you would do is set an address location. So if I set the address location to 3 with the first bit turned on and the second bit turned on, then I click set, I would now be located at the third address location. Of course it starts at 0, 1, 2, 3. And then you would hit clear and you would put a value in to store at that location by setting the bits and clicking store under memory. After you did that, it would jump to the next memory location automatically, so you could continue to clear and enter in bits for that location, hit store, and so on and so forth. You would basically keep entering in values for all the memory locations until you'd entered in your program. Now, certain values were actually used for functions, sort of like ifs and ands and thens, and to tell the computer to add, and it really depended on a string of values that you entered in. As you can imagine, it took a long time to enter a program into this. I've done some experimentation with it, and I managed to enter in a program that was a counter and basically would count up from 1 to the maximum value for 8-bit binary, and you could see it count up on the lights here. That takes a little while to enter in though, so we're going to move on to the next slide. So the Kenbach 1 actually didn't sell very well. I think only about 20 were sold worldwide, which is pretty pathetic when you think about it. But then, in 1975, we would have what would be considered the first successful personal computer, called the Altair 8800. It wasn't really much easier to use than the Kenbach, but for whatever reason, either education was finally catching up, there were a lot more electronics hobbyists in 1975. You could order this computer through mail order and have it delivered to your house, and then you had to actually put it together. It also came with a lot of peripherals, which made it much easier to use, such as a disk drive that you could get to load programs off the disk instead of having to manually enter them in, as you saw with the Kenbach 1, which could be really time consuming. It could output to a display, it could read from a tape, it could output to a tape, it could print to a printer. It really was the first what we would consider a computer, even though it looks a bit strange. I've also got a demonstration of this computer, although I'm not very versed in it because it gets a little more complex. This is a emulation of the Altair 8800, and it worked a lot like the Kenbach. You'd turn it on and you would reset it, and then you would essentially set an address, then set the bits for that address, so however you wanted them to be. You can see them being set, and then you would deposit them at that address. If you click deposit, it would just deposit at that address and stay on that address. If you click deposit next, it would deposit at that address and then move on to the next address in memory. I actually found this easier to use because with the Kenbach, when you're pushing the buttons, it would turn on the lights, which would be a good indication, but it was easier to kind of keep track of what bits were set because you had toggle switches. So if the switch was up, the value was 1. If the switch was down, the value was 0. Once you got done entering it, just like the Kenbach, you could either run the program or not run the program. Obviously nothing's going to work here because we don't have anything turned on, or not turned on, but we don't have anything real entered in. I just kind of entered in some random bits. Moving on, after 1975 and 1977, we really have what I consider the floodgates opening for the personal computer. In 1977, you would see the release of 3 different models of personal computers that were not only easier to use than the Kenbach or the Altair, but they were affordable and highly available. So the Altair, while it sold relatively well, it wasn't easily available because you had to put it together and you had to order it through mail order. So if you weren't an electronics hobbyist, you really couldn't purchase an Altair. I mean, they did sell them pre-assembled, but if you bought the pre-assembled one, it was much more expensive. So in 1977, we had, of course, the Commodore PET, which is one of the first personal computers that was essentially kind of a self-contained, pre-assembled unit. You had the TRS-80 through Radio Shack, it's the Tandy Radio Shack computer, and then you had the Apple II. And you can see here the prices kind of range, and like always, Apple II was always more expensive than every other computer on the market, which I think is kind of funny. But basically, the Apple II was really the one that kind of opened up the personal computer market. For whatever reason, people hated the Commodore PET. This one is a later model, but the original Commodore PET had a tiny, tiny keyboard that was actually kind of coined the chiclet keyboard, and nobody really liked it because it was too small. The digits on the keypad would rub off really easily, so eventually you couldn't tell what was what. And then the TRS-80, it just didn't do as well as the Apple II. It didn't have as much third-party support. It didn't have as many peripherals. I actually have a demonstration of the Apple II to kind of give you an example of why suddenly computers became much more easy to use. So we're going to restart the Apple II here. And this is the Apple II. Now, when it starts off, you're kind of confused because you're looking at a command prompt down here, and it's not like computers of today where you can just load a program. You had to know BASIC, or Apple's version of BASIC anyway, to get programs to run. I do not have any emulated disks to load with this particular computer, but I can give a basic example of its operation. So we have a simple program here. You would enter it line by line. So first line would be x equals x plus 1, and your next line would be maybe print x, and then of course a comma to keep it from just scrolling down the page. And then your third line, because we don't want this to run in like an infinite loop, would be something like if x is greater than 199, then stop, which would break our program once it hits 199. And then to create the loop, we would do something like go to 1, which would bring us back to the first line here. Once you would enter in a program into the Apple, of course you could double check your work by hitting list, and it would show what is currently entered into memory, and then you'd simply run the program, and it would run through the steps until it hits a break or a particular function that stops it, like so, break in 3. That was the Apple. You still had to be relatively smart to use it, but the great thing about the Apple II was it came with awesome documentation that was really written for the average person to understand versus the documentation of previous computers like the Altair, where you had to really know how to use binary and count in binary to use the computer. We'll show you later how loading programs in BASIC worked with the Commodore. So again, as I talked about earlier, why was the Apple II so successful? Well, first of all, it had an amazing marketing campaign. Apple was really good back in the 70s and 80s about getting word of their product out. So they did things like Super Bowl ads, print media, newspaper media in certain locations. It had a great marketing campaign. So average people were actually seeing this thing and saying, hey, I can own a personal computer too. Look at this ad. It says, why would we want one? What are we looking for in a personal computer, and how easy it is to get one. Another thing was reliability. So the Kenbach, the Altair, especially the Commodore PET, one of the other reasons it was unpopular was it was not as reliable. As I said earlier, the keys would rub off, but there was also a lot of other problems with it crashing or not working properly. So reliability, the Apple II out of the 3 computers was the most reliable of its day. Then you had a huge number of peripherals. You had disk drive add-ons, you had third-party peripherals such as a joystick here in this example, you had SCSI cards. It had a very easy to add on expansion slots. You would essentially take the top off here, and underneath there you had expansion slots that you could put these cards in, and then on the sides you had little ports that cables or plugs could plug into. And then there of course was the documentation. It came with amazing reference manuals. I went and read a couple of these before this presentation, and they are very easy to understand. They're written in such a way that you don't have to be a computer science expert to get the program to work. And then from 1977 to 1990, things just started evolving. At this point, the computer market was wide open. Many people were already owners of computers. The Apple II was very, very successful. In fact, it sold from essentially 1977 all the way up until 1993. They were still making different variants of the Apple II, which actually makes it one of the longest running computer line models ever created. to think that it was made for over 15 years.